All right, let's run through that homework. 1, 2, 3, and 4. Was everyone okay with those? Anyone need me to run through them?
No.
1, 2, 3, and 4. On 1, 2, 3, and 4, you could just go ahead and drop the parentheses, right? And then you combine like terms. So I'll just put answers up in it. Then you stop me if it's a second degree trinomial.
Yes, sir.
Is that okay?
Yep.
I'm doing these in my head, so if I get it wrong, you're allowed to point and laugh.
Yep.
Is that right?
Yep.
And then second degree tri, right?
Yep.
3. Second degree tri.
Yeah.
And we do have a new bulb ordered, so we should be a lot brighter here in a little bit. Of course, they keep arguing with me, going, but we came and cleaned it out. Okay. I don't care what you cleaned out. So that's a third degree polynomial.
What's that, 4?
Yeah, well, if there's 4 or more, you just start calling them polynomials. All right, so all of those.
I did. I got. Oh, I still would be wrong, but oh no, I got 3x squared.
Ooh, did I make a
Then
mistake?
no, you got it right.
Oh,
But I put minus 4 plus x, but that still be wrong, even though it's in like 2 different.
gotcha.
But it still be wrong.
Is it in a different order?
Because your x comes before the 4, mine came after. I mean,
Oh, I got you.
Your x is before mine.
Well, if you read the directions, find the sum or difference, then classify. So I guess order wouldn't have been important on these ones because it didn't say put it in standard form. So I think you're still right.
All right.
Cool. But you had 4 terms, right?
Yeah.
Exactly. So 4 or more terms, it becomes a polynomial. We don't really name them after that. Okay. So then I want you to take a look at number 5. Now I'm going to just write. I'm not going to write the problem out. I'm going to write it with dropping the parenthesis. All right, so the black, I just dropped the parentheses. The blue, I had to change all of the signs. Why did I have to change all the signs on the blue? It's a negative. You're subtracting, okay? So does that make sense how I have it presented?
Yep.
Okay, now this isn't done yet. Now we need to combine like terms. So now we have 6y to the third. Those are like terms, so that's plus y squared. And that, so that's plus 7y minus 9. So this one would be a third degree polynomial. Is that all right?
Yeah.
Does that make sense how I did it? Should I? Black and blue are too close. Maybe the next one I'll do black and red. See. Can I move on?
Blue green.
Blue green?
Yeah.
All right. Number 6. So number 6, I'm going to drop the parentheses on the first one. And then green. Change the signs here. Uh-oh, squeeze up there. Plus 5x. Uh-oh, squeeze. Minus 3. Is that right? So the blue, I just dropped the parentheses. Didn't have to change anything. But the green, we distributed the negative over. So all the signs had to change on those. Then I can go ahead and combine all like terms. So negative 2x to the third. And then that can combine with that. So that gives me negative x squared. That actually cancels that. And those cancel. So this is a third degree binomial. Is that all right? Oh, happy Valentine's Day, everybody.
Oh, that you too.
No, I didn't get you chocolate or flowers. It might be. Hang on, we'll get there. All right, number 7. Yeah, we'll take a look. And the ones that are in blue, I had to change both signs. Combine like terms, so I get negative y to the fourth minus or plus 2y to the third. Plus y squared plus 5. Is that it? Oh, no, there's no, that's not there. So this is a 4th degree trinomial.
Oh wait, so when you say 4th degree, you do what you saying?
That's the exponent. So when I call it a degree, that's the highest exponent. Okay. Then number 8 might be goofy, so let's take a look at number 8. Number 8, I got x squared minus 2x, and the ones that are in red, I got negative x squared minus 2x. So I had to change both of those. Is that okay so far?
Yeah.
All right, so the reds have their signs both changed. So the x squareds are gone, and I have negative 2x and negative 2x, so if I combine them, I get negative 4x. So that is a 1st degree monomial. 1st degree monomial.
Wait, negative 2.
Negative 2 combined with negative 2 is
But
negative 4.
I got negative 2 on the other one because there's a negative in between the parentheses.
So here, so that's the same, right?
Yeah.
Then this one became a negative x squared, and that was a plus 2x, now it's a negative 2x. When you distribute it to both.
Because Mr. wouldn't both? Yeah.
So this sign and this sign are changed because we,
Oh, and 2 negatives is a positive.
when you combine them together, they stay negative. If you multiply them, they go positive.
Oh, that's why I got it wrong. I probably have to add them.
All right, we good up through 8? All right. Number 9. So I'm just going to do this. I have this plus another one of these from the top and the bottom plus one side plus the other side. If I add all that together, being those are all the sides, that'll come up with the perimeter. So 2x and 2x is 4x, 5x, 6x. That's 14 minus 4 is plus 10. So the perimeter with relationship to our sides is 6x plus 10. Does everyone understand why I got 2x and 2x? The top was 2x and the bottom, if it's a rectangle, it has to be 2x.
I got 3x plus 10. I mean plus 5.
Oh, I see what you did. Because you only added one side, one top, and one side. But you have to
So you're
identify.
supposed to do 2x plus 7, 2x plus 7.
Yep, you have a top. You have the top, which is 2x plus 7, and then the bottom's also.
It's size. I get it.
Can I move? Go on. All right, number 10. So let's see, I have 4x squared minus 8 plus the next side is x squared minus 2x plus 6 plus the last side is 4x minus 2. So if I add all those together, I'll get the perimeter because it's all the sides. So I have 4x added to 4x squared added to x squared, that's 5x squared. And combine that and that's plus 2x minus 10. So that's the perimeter related to our sides that were given.
Would that one be on a 10?
I don't know, maybe. I'd say you see the perimeter one. All right, so 9 and 10, you know what all the sides are, so you just add them together in order to get to what the perimeter is equal to. When you get to 11, they already tell you, say, hey, this is your perimeter of your whole shape, and you know this side and this side, those two sides, if I add them together, I'm still missing the third side. Thank you. And yeah, okay. So I know two of the sides, right? But I'm missing the third side. Agree?
Yeah.
So, and that was a triangle. So I'm going to put plus this square. Okay? That's going to be one of the sides. Is that okay? So I know that if I add up all three of the sides, they'll have to equal the perimeter, and they told us the perimeter is this. Agree? Make sense?
Yeah.
So now what we want to do is we want to move everything over to here and leave the box over here. And that'll tell us, that box means that's our third side. This is our missing side. So missing side. Let's see. So 6y minus 2 plus the missing side equals 7y minus 12. I just combined like terms on the left. Is that all right? Hey, tripping. If I subtract 6y, bring it over here, this becomes a y. Agreed? If I add 2, that becomes a negative 10. So my missing side is y minus 10. Yay? Those extras? Thanks. All right, number 12. Number 12, they have a rectangle in which they said, hey, this rectangle has a perimeter of this. So, and if we draw this shape, okay, so they tell us that the perimeter of this rectangle is this, and we have one of the sides being 3x minus 8. So this also has to be 3x minus 8. Do you agree with that? Yeah. And did it work okay if I did a box? So I have a box here and a box here. Those boxes are this, whatever those lengths are. Agreed? So let's do what we know how to do. If I can add this and this together, so I'm going to get 6x minus 16 plus the two boxes. The boxes is unknown, right? And I get this. What do you think? Does that kind of make sense, what I just did?
Yeah.
It's not done yet. It's just, what I did is I knew one side was 3x minus 8 and the other side was 3x minus 8. So if I add those together, I get 6x minus 16 plus the top and the bottom, which we're just calling boxes.
So where'd you get the 2 from again? Plus 2.
Oh, because I have
1, 2.
2 of them.
Okay.
All right, subtract 6x. So that'll become an 8x. Add 16. That becomes a plus 4 is equal to 2 squared. Square, again, is our unknown side, right? And yeah, I'm using a square to make it like a variable so we don't have to, think it's all kind of goofy. So how big is just the individual unknown? How would I solve that? What math would have to take place just to get to this? And this would identify to be one of those. What would I have to do? How are these being held together? Multiplication. So how would I undo it? Divide. So if I divide, that's 4x plus 2. So 4x plus 2, 4x plus 2, and 3x minus 8, and 3x minus 8. We good? All right. Don't worry about the rest. Make sure your name's on it and pass it on forward, please. So much. All right. Let's get to the top of this. All right. So naming using the degree. Okay, so it's second degree, right? So that's a what? Starts with a Q. Quadratic. Is that right? This is fourth degree. What was fourth degree? It also started with a Q. Real close. Quartic. Okay. Third degree starts with a C. Cubic. X is raised to the first power, right? So it's linear. Good. 7x. X is raised to the first, so it's linear again. And then to the third? Cubic. Okay, is that okay? Okay. Name using the number of terms. Okay. So if there's 2 terms, it must be a binomial. 3 terms? Trinomial. Tricycles have 3 wheels. Trinomials have 3 terms, right? Bicycles have 2 wheels. Binomials have 2 terms. 2 terms? Binomial. 2 terms? Mono, good. And then there's 4 terms, so it goes right to a polynomial. And anything beyond 4 or more is just called a polynomial. We don't have a special name for it. I guess we got lazy. Okay. Leading coefficient. Remember, the leading coefficient goes with the highest exponents, the base of the highest exponent. So what's that? -1. I like it. What about the second one? It's just 2. You don't have to have the x with it. Just put the 2. Put the number, okay? What about the next one?
1.
Yeah. Next? -1. Good. Next?
8.
7. Oh, you were one ahead of us. -8 is the last one. Indeed. Perfect. Cool. Is that a tough thing to do, you think?
Memorize.
I mean, I think you're okay with mono, bi,
Yeah, mine
tri,
quad.
quadratic. So, yeah.
I'm still confused about quad.
Quadratic is something that's raised to the second power. So a quadratic function makes something called a parabola, which we're starting to get into. We're not there yet, but we will.
Isn't quad like, what is it?
That's the goofy thing. Doesn't quad mean 4?
Yeah.
It's dumb math, people.
Yeah.
So if there, yeah. So which one are you looking at? Yeah. So 2x to the 4th. That's where it becomes quartic, trinomial, because there's 3 terms, and then we use that as our base because it was the highest exponent, even though the order was goofy. Okay. All right. Life good? Oh, did I unmark Jake from being here? Jake, you sure, right? Sweet. All right. Can I move to the next one? So, the word wall, I mean, quadratic, quartic, cubic, linear. If it's just a number, it's called a constant. Yeah. Then we have, I mean, I guess we could throw anything on this we wanted to, but it's basically any of those words that we just used. Do what? Number of terms, so, monomial, binomial, trinomial, and polynomial. I mean, those are just some things. They're there. I mean, go to the Latin roots: mono, bi, tri, poly. Poly means many in Latin. The wonderful dead language that we still go back to. Actually, I took Latin in high school. Took it for 2 years. Where'd you take it? Really? It wasn't that bad. The nice thing is, because I grew up in Arizona, so we grew up right around a bunch of Spanish. So Spanish is like 60% the same as Latin. Where'd you grow up? Tempe, Arizona. What's that?
When I lived in Arizona, that's when I learned Latin.
Yeah? What high school would you have done to?
I would say I was still in Phoenix.
Gotcha.
Are you still speaking?
Huh?
Are you still speaking?
Let's see. Eke Puella means look girl, or Eke Puella means look boy. Bogus Sturkus means bull dung is the appropriate thing.
Mister, what is what's it called? Cortex. What would that be like? 1, 2, 3, 4, 5.
Something to the 4th power.
Cortex is 4. Oh,
So that's what the exponent is.
poly.
Alright. It could be a polynomial, but you could have like 5x to the 4th sitting alone, so it's a monomial, but it's quartic.
What would constant be?
6.
Like 12, 6 and above.
2. Doesn't have a letter.
What's number 1 in Adam say?
Number 1. What do you say?
Oh, like 11 long. I know.
No, it's mundo tray. So they don't go. It sounds a lot like Spanish, but it's mundo tray quad.
Oh, in that what language is it?
Latin. I wanted to be a doctor when I was in high school, so I took Latin. Now I'm a teacher. A lot of the bones in your body are Latin roots,
Oh. So
and
it was
a lot of medications are Latin. All right, polynomial multiplication. Okay. So let's do this. I'm going to use the distributive property, so I'm going to multiply 2x times here, 2x times here. So that's the same thing as saying 2x times 3x squared minus 2x times 4x. Is that okay? Then we'll do the math. 2 times 3 is 6. Like bases, when multiplying, we add the exponents. Remember last chapter? And then this one's going to be minus, and then 2 times 4 is 8. X times x is x squared. So the distributive property is used often. Is that all right? Can I move on? Yeah.
So then how come you can't subtract the 6x from 8x?
Because 1 is to the third power and 1's to the second power. Now, let's go with the boom, boom, boom of this, okay? That would be like, so you know what a cube is, right? Like take a shoebox, you with me? Which is a third dimensional object, right? And then you're subtracting a second dimensional object like a piece of paper. So you're subtracting a piece of paper from a shoebox. Could you do that? It's not going to happen. It's like awkward to say that, right? So that's why they're like terms. So remember I said the exponents are dimensions. So you're taking a third dimensional object and subtracting a second dimensional object. When you add, you would just be able to combine like terms. Yeah, but yeah, exactly right. Add, subtract, they'll share the same property. You can multiply because multiplication, you improve a dimension. That's really the fundamentals of what you're doing, even though it's not in any textbooks. All right, so problem number 1. Let's see if we walk through this. There's my first thing. So it's what is going to be 2x times 3x squared? So 2 times 3 is 6, and then x times x squared is x to the third. Okay, and the next one, I got a minus in there. What's 2x times negative 4x? 8x to the power of 2. Good. Why is it the power of 2? Because we're multiplying the bases, and each of the bases are an exponent of 1, right? Talk to me.
Why? Like how the 2 is represented, why is it not just set
Oh, could it?
next to it? Is it easy for me?
They just put it that way.
Why did you distribute it to 6?
Oh, I haven't gotten there yet. Plus 12x. Is that all right?
Why not add the power?
I can't. Do what?
Wouldn't it be just square?
Because I was multiplying just a number times a constant, yeah. Or a monomial times a constant. All right, so the next one. So this 2x is going to go here, here, and here. So that's the exact same thing we just did up there, right? So if I do that, I'm going to get this. But now we got the little brother of negative 3 that comes along. So negative 3 times 3x squared is negative 9x squared. Negative 3 times negative 4x is positive 12x. And negative 3 times 6 is negative 18. Okay, so the black was me distributing the 2x over the parentheses. The blue is me distributing the negative 3 over the parentheses. Now we have to look to see if we have like terms. Okay, so I have 6x to the third, so that's took care of that. If I combine negative 8x squared, that I get negative 17x squared. combine the 12x's, so that's plus 24x. And then minus 18 comes along. So that whole thing is my answer. So I combine my like terms, and a like term, remember, it's the same letter. That letter happens to have the same exponent it's raised to. So you're just counting up. So I distributed twice on number 2. What does it appear I might have to do on number 3? Distribute 3 times. So my first is here to here, here to here, here to here. So that gives me my 3x to the 4th minus 4x to the 3rd plus 6x squared. Then I'm going to distribute it's here, here, and here. That's going to give me plus 6x to the 3rd minus 8x squared plus 12x. Then the green, I'm going to take the negative 3, go here and here and here. I'm going to get negative 9x squared minus 12x, minus 18. Couldn't quite squeeze it. Okay, so the blue is me distributing x squared, the red is me distributing the 2x, and the green is me distributing the negative 3. Now we need to combine like terms. Okay, so nothing else raised to the 4th, so 3x to the 4th. To the 3rd and to the 3rd. So we'll combine those, so plus 2x to the 3rd. Second, we have a few of them. So 6 minus 8 is negative 2. Negative 2 minus 9 is negative 11. X squared. That and that, they cancel each other out, right? So then I'm left with a minus 18. Someone has a singing Valentine out here. Let's hear the music in the hall. You hear some harmonizing. Am I going too fast, or are we okay? How many more slides I got? 1? Oh yeah! Let's finish this up. Last slide, right?
No.
No?
We have like 2 more after this.
Oh. Wait, where do we go? There? Oh, there we go, right?
Yeah.
We good?
Still 2 after that.
Okay, we can get there. All right. So I'm going to distribute how many times on number 4?
2.
Twice. So the first one, I'll distribute the x here and here. So x times x is x squared. X times 5 is 5x. I'm going to distribute negative 2 here and negative 2 here. So I get minus 2x minus 10. How does that look? Question? Nope. That's right. Combine like terms, so x squared plus 3x minus 10. What do you notice about 2 of the new terms? I don't know. All right, let's do this one. What am I going to distribute? How many times am I going to distribute here? Twice. So first one, the 3. Yep. Wait. Did I do it right? Do we agree? So 3x times 4x is 12x to the 4th. 3x times 3 is 9x. Negative 1 times 4x is negative 4x. Negative 1 times positive 3 is negative 3. Combine like terms, so 12x squared plus 5x minus 3. All right, moving on. Yay. We good still? Everyone happy? Okay. How many times am I distributing? Twice. So I'm going to multiply the 2x here and the 2x here. So I get 2x squared plus 8x. Then 2x and 8. Is that all right? Shh. Last thing, combine like terms. That okay? Is this the last slide?
It's just one more.
One more, okay.
Well, then you do have applications.
Oh, okay. All right. Number 7. I'm going to distribute twice. So a times a is a squared. A times b is ab. So that's plus. Negative b times a is negative ab. Negative b squared. These are the opposite terms. They cancel out, so I wind up with a squared minus b squared. So a plus b and a minus b, it's called something called conjugates of each other. So it means they're the same binomial with one opposite sign. And whenever you multiply that, you wind up with just two terms. Last one. And there's nothing after this? Yay! Okay. All right. Ooh, find the area of the triangle. Shoot. What's the equation to find the area of a triangle? Y equals mx plus b? That's linear equation. Yeah.
A times, well, length times width divided by half.
Okay. So length times width divided by 2. Sometimes you might have heard this as 1/2 base times height as well. So either way is the correct way to think about it. What you need to know about the base and the height, or the length and the width of a triangle, is they have to be perpendicular to each other. Okay, which they are. They form 90 degrees. So let's see. I'm going to go 6x minus 4 times 2x plus 5. And we'll do 1/2 of that eventually. Is that okay so far? So that'll find us the area. So let's not worry about the 1/2 right this very second. Let's take care of the 1/2 at the end. So we'll have this at the very end. So I'm going to distribute twice. So that times that is 12x squared. This times that is 30x. This times this is minus 8x. And this times that is minus 20. Agree? Now we still have that 1/2 to deal with, but let's combine like terms first. Okay, so 12x squared won't combine. And then I get plus 22x minus 20. What should I do with that 1/2 now? I need to distribute it, okay? So I'm going to go 1/2 times 12, that's 6x squared. 1/2 times 22 is 11x. And then 1/2 times that is negative 10. So the area,
Mister.
yes,
Well, you wouldn't combine the 12. Oh, wait.
no one had an x and
Oh,
one
I
had.
see.
Okay, so that is the area of the triangle related to our polynomials. Okay? So your assignment for this evening is page 43 and 44. Page 43 and 44. No, there's on page 44, we snuck in 4 problems.
That's not bad.
So again, guys and girls, if you do want extra help, I am available every morning except for Friday before school. And then, or if you happen to share an off period with me, either 1st or 4th, and sometimes the beginning of the 6th, but you got to double check with me so you can come see me, okay?
What page is this?
43 and 44.